Okay, so in the last part of this video, what we're going to do is look at some practice problems. I'm going to go over the example problems and give you some suggestions for the practice problems that follow that example. We're going to start with the part one, which is determining the half-life. So these are problems where you're asked to find the half-life. So just to recap, the steps for all of these problems are the same. You want to identify your given and what you're asked to find. In this case, will be the half-life. And then for step two, you want to find the half-life cycle using either a data table that you create or is given to you, or an equation. Now, one thing I didn't note in the previous video is that the equation always works. So you can always use one of the two equations to solve for half-life cycle. The thing that does not always work is the data table. And the data table only works when the number of times you divide by 2, when you go from initial to final amount, is a whole number, right? So if we look back at the previous example that we went over, we divided by 2 4 times to go from the initial to final, so we can use the table there. But if, let's say, for example, after I divided by 4 or 5 times, my final amount was in between 2 of those amounts, then I know I can't use that table because I can't divide by 2 a whole number of times to go from initial to final. So just note that you can't always use a data table, but if you can, it's useful and it's quick. Okay, so with that being said, after you find the half-life cycle in step 2, either using a data table or an equation, you're then going to use the other equation to solve for what they're asking you to find. So let's take a look at example 1 together again. We have the initial amounts. They're telling us we're starting with 7.5 milligram sample of chromium-55. Is analyzed after 14 minutes, so that's our elapsed time, and found to contain 0.469 milligrams of chromium-55. So that's our final amount, and they want to know what the half-life is. Okay, so I have my given, this initial and final amount, and elapsed time, and I'm asked to find the half-life. That's step 1. Step 2, using data table or an equation. So I'm going to show you the work for the data table. In this case, they did not provide a data table for us, so I had to create one. And remember to create a data table to use to find your half-life cycle. What you're going to do is start off with your initial amount and then just keep dividing by 2 until you get to the final amount, and the number of times you divide by 2 is your half-life cycle. Okay. You can also set up the left column where your x column would be your independent variable. The number of half-life cycles will be 0, 1, 2, 3, 4. So basically the first half-life cycle has to start at 0, and then whatever the number of half-life cycles you went through to get to your final amount will be the half-life cycle value. Okay, so that's using the data table. Now, let's say we didn't want to use a data table, or maybe we couldn't. In some cases, we can't. So we can also solve for a half-life cycle by using an algebraic equation. And in this case, since I'm given the final and the initial amounts, I'm using this algebraic equation. So I just want to quickly remind you there are 2 you can choose from, but since I'm given final and initial amounts in this problem, I'm going to use this one. All right, so I plug in my values into the equation, and then I'm just using my algebra skills to solve. So my unknown is the number of half-life cycles, so I cross multiply to get it out of the denominator. Then I divide both sides by 0.469 to further isolate it. And then that gives me 2 to the power of half-life cycles is 15.99. So in that case, then I'm going to need to use some sort of logs to solve for that. So remember that with logs, if your calculator allows you to solve for logs, great. What you would do in this case would be log base 2 of 15.99 is will give you the answer number of half-life cycles. But in case you cannot use your calculator for it, you can use the common base property of a log. So in that case, whatever would go in the parentheses, you take the log base 10 of that, So log base 10 of 15.99 and divided by log base 10 of your base of your original log. So basically you take the number, the larger number that goes on top and that smaller number goes on the bottom, take the logs of both of those numbers, and then you would get the same answer. So this is if your calculator doesn't work that way. Alright, so that's step 2 done in our procedure. We found the half-life cycle either from our table or from algebraic methods. Once we have the half-life cycle, then we are going to use the other equation. In this case, they're looking for the half-life, so we would use the equation that contains half-life, so equation 1. And we will plug in our half-life cycle and the elapsed time which they gave us, okay? And so that's my work shown here. I have 4 as my half-life cycle, 14 is my elapsed time over half-life. I'm just going to cross multiply and solve for half-life, and I get 3.5. All right, so on the rest of this page you have a similar, you're solving for a similar thing. It's the half-life. So the answer key will be provided, and you can check that out in Schoology. There's one thing I want to note, because question 3 is a little different. In this case, this is one where you are given a table, but remember, you can try and use the table when possible, but in this case, since they do not give you the elapsed time, you can't use the table here to just keep dividing by 2, because you don't know until when you need to stop. They also don't give you the final amount, and we're asked to find the half-life in this case as well. So what you want to do is you want to revert to using the data table to find out some other key information. Like, for example, you can use the data table to find an initial and final amount over a given amount of time. Okay, so they have the time here in days, so that will be your initial amount, and you can choose any one of these as a final amount. So let's say, for example, I choose this as my final amount, then if I chose the 0.6065 as my final amount, then my elapsed time would be the 5. All right, so you're using the data table to get initial and final amounts and elapsed time. All right.